Hi everyone and welcome to this video on further maths. Yes indeed, further maths over here in Australia, and it is really good to see you. What am I dealing with this time? It's the log scale to display data. So using the logarithmic scale to display data. And you're going to say, what on earth is that all about? Well, basically we can use a different scale because sometimes numbers get too big and we have to sort of fudge them. So if you're following along with the Cambridge Further course, then this is the video for you. It's really good to see you. I am Darren, otherwise known as the Maths Guru, and if you're new, can you do me a massive favour? I am a small person trying to do a very large job. Believe it or not, there is me sitting in a room talking to myself. No recording crew, just me. And it's hard work, but it makes it all better if you can subscribe by clicking that red arrow, whatever it's pointing to, because it makes me know that people are actually watching these videos. Greatly appreciated. And my lessons are a mixture of humour, real world, and hopefully some freaking awesome teaching, if I do say so myself. Now, I normally start with a recap, and this stuff is in fact building on all the stuff we have done before. So there are previous videos that you can load up in the playlist on YouTube or on mathsguru.com, the website that basically just holds all this stuff for you. And if you don't know, we're already dealing with the core data analysis part of this course, which is dealing with categorical numerical data and how to display it. Now we're almost at the end of this actual chapter, which is tying in very well with the Cambridge Essentials, the Cambridge Further textbook series. What we have to do though, and it comes up over and over again, is deal with logarithms. And I'm going to sort of explain to you why we need logarithms. It's also, funnily enough, on the Math Methods course. Don't switch off. It is fine. It's actually a relatively simple concept. So why on earth would we need to use something called logarithms? And in fact, what are logarithms? Well, if you look at the data now above me, what do you notice? Well, I've said I've gone into and done some sort of an experiment, and every day I'm going to walk in and count, let's say, bacteria in a petri dish. Now, bacteria are known for growing really, really quickly, very much like babies. So, you know, when the little fishy thing goes into the eggy thing, then there's subdivision of cells. And we have 2 cells and 4 cells and 8 cells and 16 cells and 32 cells. And it keeps exploding until, strangely enough, we end up looking like this if you're really unlucky, or looking like you if you're really, really lucky. And so I'm going to walk in and I'm going to count bacteria. And this table says on day 1, there were 5 cells in my petri dish. Okay, I counted click, 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 and then I walked out. Now the thing was, I'm not very good at going back, and I went back on day 10. And actually day 10, there were 4.5 cells. I don't quite know what happened to the half a cell, but okay, fair enough. And then I thought, well, this isn't really going very well. I was expecting this explosion, so I went back on the 100th day, the 1000th day, the 10,000th day, the 100,000th day, and it's really hard to say that quickly. Now, obviously, trying to plot that on a graph would be really, really challenging. Bearing in mind, when we have an x-axis, we normally go 0, 1, 2, 3, 4, 5. We may even go up in tens, 10, 20, 30, 40, 50. But we wouldn't have a scale or an axis that goes on for too long. We try and fit our data into that. Could you imagine what this would actually look like? Imagine I'm drawing this line now. Imagine this is 0, and always down here is the 1. Maybe here is 10. Maybe up here is 100. Maybe over here is 1,000. Maybe all the way over here is 10,000. And then, well, we won't even get to 100,000 or a million. And basically, we'd have a little kiss at 5, a little kiss at 4.5, maybe a kiss at 6, maybe a kiss at 9.8. And I know I'm not doing this very accurately, but what do you notice? This data is massively spread out. So far, in fact, it would make no sense to us whatsoever. We couldn't look at any patterns. We couldn't look at any relationships that we're having between this data. And so, actually, it would be amazing if we could actually come up with a whole new number system. Now, I don't mean some sort of Star Trek or Klingon or, I don't know, some sort of system. But let's go back to what we were actually looking at before. So this is my table, but funnily enough, written in an exactly different way, in a really different way. So we know that 10 to the power of 0 is the same as 1. Anything to the power of 0 is actually always 1. We know that 10 to the power of 1 is really a 10. We know 10 to the power of 2 is 100, 10 to the power of 3 is 1,000, 10 to the power of 4 is equal to 10,000, and so it goes on. And so, confirming or checking this with the table above, we said that 1 could be written as 10 to the power of 0, tick. We said 10 could be written as 10 to the power of 1, tick. 100 could be written as 10 squared, 1,000, 10 cubed, and so it goes on. So what I've now done is I've taken my table here, as you can see, and I've effectively just renamed the x values, 10 to the power of 0, 10 to the power of 1, 10 to the power of 2. But again, that hasn't made it any better. If I still try and draw this, we know 10 to the power of 0 is 1, we know 10 to the power of 1 is 10, that's 100, that's 1,000, this would somewhere over here be 10,000. It's really not helped us, or has it? Well, what if we changed 10 to the power of 0 and just said, okay, we'll redefine that, or we'll now think of that as 0. We'll take the power as the counting number. What about if we had 10 to the power of 1 and we said, let's just make that 1. And 10 to the power of 2, make it 2. 10 to the power of 3 becomes 3. And you see what suddenly has happened? Well, my old values were written here. So 1, 10, 100, 1,000, 10,000, 100,000. And we're now saying, well, let's actually redefine my number system. Let's call it 0, 1, 2, 3, 4, and 5. We're actually going to make the powers the new number system. And if we were to draw that, well, once we label our graphs, 1, 2, 3, 4, and 5, and then we got the values of 0 would now be 5, 1 would be 4.5, 2 would be 6, 3 would be 9.8, 4 would be way up here, and 5 would be actually massively down here. We can now see our data much, much better. And ladies and gentlemen, to be able to turn our 10 to the power into a counting number is called logarithms. And the great thing is your calculator can do this for you. Now, we also need to know that actually small numbers can also be expressed as logarithms. Now, what we notice here is that if we had 1, and if we keep dividing by 10, each number dividing by 10, then we get the next 0.01, 0.001, and so it goes on. Now, these are actually can be expressed as powers as well. So this here is 10 to the power of -1. This is 10 to the power of -2, 10 to the power of -3, and 10 to the power of -4. So again, we could think of this number in our log scale as -4. We could think of this number in our log scale as -3, this number is -2, and this number is -1. Now again, if you don't fully understand what's going on, stop, replay the video. Probably not going to make a huge difference as long as you can use your calculator to be able to do this with you. Now, Megan Trainer said it's all about the base, but in this situation, it's about the base, not the base. It's not about the it's about the base of logarithms. And we need to know that actually we're going to use logarithms to the base 10. Now what that means is when we had 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, this thing here is actually called the base of the logarithm. That's the thing we're going to say, well, let's turn that into the floating number. We could also have base 8, believe it or not. And if we decided to have a base 8 counting number, then all it means is that this here is an 8. We'd still count the numbers 0, 1, 2, 3, and 4, but we have 8 to the power of 0, 8 to the power of 1, blah, 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 blah. So how do we actually use this on our calculator? Well, the good news, I have my calculator ready and loaded, and it would appear there is a question here extracted from the Cambridge Further Maths textbook. Yay! So I've loaded up my calculator, and as is normal, let's put it in main. There is nothing on my screen at the moment, and it says find the log of 45. So I suppose the first thing we need to do is find out where our logarithm button is. Click the keyboard on the Casio ClassPad. If you're a TI Inspire user, my apologies, don't really have the TI Inspire with me, but I will do videos at some point with instructions on how to do it. So we've loaded it up, and a red arrow is now pointing to log 10 with a squidgy thing. Do you see it there? And there we go, log 10. Now this is one of the ways of doing it. I'll show you another way in a moment. Because all of our numbers are going to be log 10, I can now put 45 in here, close the bracket, press enter, and out comes 1.653212514. What does that actually mean? It means that 10 to the power of 1.653212514 is equal to 45. Whoa, this is awesome. Let's just check. 10 to the power of my answer. So drag my answer down, press enter, and 45 it is. Could life get any more exciting? Now, I said I was going to show you another way of doing it. There is another way by using this button here. Now, it does it in a slightly different way. This is when we want logs. Now, you'll notice there's two little squares we've got to fill in. The bottom one, the one below, is looking for the base. And you will always use base 10. So that's the first one done. And then I put 45 and I hit enter, and whoop, whoop, once again, out comes the value we were expecting. So that means that this log button tells me the floaty number when I'm given the whole number. And actually this second part, when it's find the number whose log is, when they're giving you the log, they're actually saying, well, 10 to the power of 2.7125 is equal to what? So being able to read the questions is probably the most important part here. So banging that into my calculator, let's bring it up. Oh, what do we have? So we had 10 to the power of 2.7125. It wanted to express to the nearest whole number. And so we would have, and be very careful there, 516. Yes, because that 0.8 would mean it would need to round up. So we'd write in here 516, and you have logarithms down pat. Now we started off by talking about how logarithms were really, really useful for graphs. You get that? So let's have a look at it again and see how we're going to use the logarithms to help us draw histograms. Now histograms we were dealing with in a previous lesson. So if we look at the graph here, let's imagine we had a number of animals that we looked at their body weight. Now obviously the body weight of an ant in comparison to the body weight of an elephant would be significantly different. And so that's where we have that difference in numbers. So if we look here, we've got a histogram that really is not very helpful to us. Why? Well, we have all of our data squidged up on one side and a very, very tiny bit here at what would seem to be 85,000 to 90,000. We have that massive bar at 0 to, what would that be, 5,000? And it doesn't really help. So what we're now going to do is say, well, okay, we can now use our idea of logarithms to turn this really big scale into something going 0, 1, 2, 3, 4, 5, and so on. And when we do that, ladies and gentlemen, what do we notice? Now, first things first, we know that the logs have been taken. We know that we're using this logarithm scale, this special 10 to the power of scale, because of what it says on the bottom. Log body weight. This log thing here, very, very important. We've got percentages, and now we notice that our graph goes between -2, -1, 0, 1, 2, 3, 4, 5, and 6. And if you remember that a log value of -2 is equal to 0.01, okay? So that's like a really, really small. So obviously a percentage of the animals here had a very small body, maybe an ant, for example. So you're going to be expected in further maths, so I promise you to be able to do this. So let's take an example now from the Cambridge Essentials textbook and see how we actually use logs in terms of the questions. And it just so happens that the question I showed you a moment ago is the graph we have here. So first things first, whenever I answer these questions, I need to know that the values are logs. The histogram shows the distribution of the weights of 27, so that's going to be important to me. Animal species plotted on a log scale. Thank you. What body weight in kilograms is represented by the number 4 on a log scale? So they're saying to me, 4 is my log. How do we go from logs to ordinary? Well, for part A, I say, well, I know that's 10 to the power of floaty 4. Bringing up my calculator, 10 to the power of floaty 4 gives me, 10,000. Probably could have done that in my head, but this is a CAS course. And so 10,000 kilos. The question said in kilos. I'm going to write 10,000 kilos. That wasn't difficult because I now understand what I'm looking for in the question. Part B. How many of these animals have body weights more than 10,000 kilos? Well, actually, part A helped us. So reading along my scale, I'm going to read along and draw a dotted line across and across and across and across. And I think that's 8%. So 8% of my total animals are above 10,000 kilos. So we're looking for 8% of 27. How do we do that? Fire up my CAS calculator, and we're going to do 8 divided by 100 equals, and we're going to times that by 27, and lo and behold, out comes my fabulous value of 2.16. Well, we're not going to have 0.16 of an animal. That's probably a tusk or a trunk or something, and that's probably not necessarily a good thing. So we're going to round that to make it a sensible value, and I would suggest there then we have 2 animals. See, all we're doing is being able to read the scale. The weight of a cat is 3.3 kilograms. Use your calculator to determine the log of its weight. So they're asking you to work out the log of 3.3. Okay, so the log to base 10 of 3.3. Again, I can't do that in my head. Load up my calculator, select the right function on my calculator. So let's just do this one here. Where are you? Oh, that printed in the wrong place. So obviously I had my keyboard in the wrong place. So let's put that one there. So log base 10 of 3.3 gives me the wonderful value of 0.5185, blah, blah, blah. How do I round this? Well, the question tells us. It says correct to two significant figures. And in that situation, if you know how to round to two significant figures, it is 0.52. And so there we go, 0.52 would be the log of 3.3. And part D says determine the weight in kilos whose log weight is 3.4. So it's done it backwards. It's now saying the log weight is 3.4. How do we go from a log weight to an ordinary weight? Well, we do 10 to the power of the log weight, which is 3.4. Fire up my CAS calculator. 10 to the power of 3.4 equals, and once again it says to the nearest whole number, so that would be 2512. 2512. Well, we're almost there, ladies and gentlemen. Another long lesson. I'm so sorry about this. God, I try and make these informative but short, and I am failing miserably. We're now going to use the CAS calculator, and this very much builds up on what we had previously. So in a previous video, we talked about creating a histogram using the CAS, and I'm going to show you how to do that now. So loading up my CAS and putting it back into my main mode, obviously I'm going to choose statistics because this is a module in statistics, and it just so happens I have all of this pre-done. Now what you notice is the top of my column highlighted with a red arrow now says weight, and I did that before I put all of my values in. So all of my values there line up with everything in that table. Now the question says construct a histogram to display the distribution of the body weights of these 27 animals. It says nothing about the logarithm, it just wants the body weights. How do we do this? Well, we press the button that brings up the graph, you know, the set stats graph. We want draw on, but we certainly don't want this XY line because we want a histogram. What list do we want? Well, I'm actually going to scroll down and I'm going to look for the one that has the word weight in it. Now it may say main/weight, that's okay, that's a calculator thing. It's important that I see the word weight, select it. My frequency, we want my frequencies to go up in ones, and so I'm going to hit set. The graph has now all been set, but I've got to tell the calculator to draw it by hitting that button there. Now the calculator, if you notice, is saying H start 0. So it's saying what value do you want on my x-axis to start from? It's saying, well, I can choose 0. I'd probably let it choose what it thinks. But this H step interval of 9,670, we're actually going to set it to 5,000. Why? Because that seems like a good value to set it to. And we're going to hit OK. And then it is going to draw this most awesome and, well, actually, no, not awesome. Now, do you see what's happened? Because we've got all of these values. It's squidged them at the beginning. It's got one at the end. It's completely readable and not very helpful to me. So, all right, we've done it in part A. But then part B says the log body weight of these animals and describe its shape. All right, we can do this. We're going to do the log body weights. Well, first things first, I'm going to hit the close button to get rid of that graph. Now, obviously, I want to close the graph box, so it's got the blue line around it, and then I'm going to hit this little X at the top, if I can see it under the studio lights. And now it's the list 2 I want. Now, I'm going to call this LWT. I want to change the name of that. So I'm going to go down there, delete it, hit keyboard and ABC, and then I'm going to do LWT. Set execute, and it's going to change the top of that. Now, you'll notice that there's a load of values in there. That's because I previously did this, and I hate the fact that it's done that. So what I'm actually going to do is change that and actually call it something else. LWT, let's call it WTT, because that won't be in my memory. There we go. So having chosen LWTT, I'm going to go back and I'm going to go down. And what I want to do now is I want to say to the calculator, I want you to calculate something for me. So the red arrow now is saying, when we want it to calculate something, we're going to put a formula into that little box there. Now again, I need my keyboard because I'm actually going to type in LOG to say log. Then I want to do an open bracket, and I want to take the log values of all of my weights. Okay, so this time we're saying, well, we don't want the ordinary weight. We want the log value. So log, and we have to type W-E-I-G-H-T, because that's what I called that first column of numbers, weight. When I press execute, you'll notice that suddenly all of those values now populate. What it's effectively doing, as it says with that red arrow, is it's taking all the weight values and it's taking the log of them. What I'm trying to do, well, the question says draw a histogram. So I'm old hat at doing this now. So I'm going to set my graph by hitting that little button. Histogram, but this time I don't want main WT weight, I want LWTT, I want the log of the weight. Frequency stays as 1, hit set. And let's see whether we can draw it. Now it says H start at -2. Again, it's auto-suggesting. It thinks the smallest value of my log is -2. What do we want to be as my H step? I'm suggesting, what do you reckon, 1. And then let's go H step, OK. And lo and behold, as you can see, this now will start to draw the most amazing graph. And again, if we want to find values, I hit this little XY button up here. And once again, you can see that, so for that little cross there, it says, for the interval starting at -2, we have a frequency count of 1. And if I move it all the way across to one of the highest ones, for my, what is that? For my log of 1, then I know I have a frequency count of 7. This stuff is amazing. Well, ladies and gentlemen, that is it. Well, that is it, ladies and gentlemen. Yes, that is the end of the lesson. I will go to the other side of the screen. And there I am, and now I'm going to start to grow bigger. Why? Because this is the end of the lesson. Yes, I know this is the stuff you want to skip, but stick with it for just 20 seconds longer. If you haven't already done so, thank you so much for being here. It'd be great if you subscribe. Over there is a circle that is clickable for you to subscribe. Tell your friends, tell everybody out there that these videos are there and hopefully useful. If not, there is a video loading below from the Further Maths course. It's been really good seeing you. Hope you're well. Have an awesome day. Maths Guru, out.